Welcome in dark core. Space is full of diverse objects we don't know much about. That's why they capture our interest every time we spot them. But with this thrill often comes fear, especially whenever there's a comet heading toward us. It's no surprise we haven't got a clue on how to stop an asteroid or comet from hitting the planet. But soon, having such technology might become vital. Now scientists operating one of the most advanced astrocameras have just made an eye-opening finding. They detected a monster comet that is already in our solar system, and it's moving fast. The discovery in August of 2013, scientists launched a project to map a portion of the southern sky which completed in 2019. It's called the Dark Energy Survey. An incredible 570 megapixel camera called the Dark Energy Camera grabbed data from over 300 million galaxies amounting to 50 million megabytes. Scientists have just begun to go over that data, and they found something that they didn't expect. Data created 32 images showing a blurry dot in the darkness of space, located about 2.5 billion miles, 4 billion kilometers, away from Earth. It wasn't until it got close to the planet Uranus, about 3 billion kilometers, 1.8 billion miles, that astronomers were finally able to figure out what the strange object was. What scientists detected was a comet with a size 1,000 times above average. It was dubbed C 2014 UN 271, also known as Bernardinelli Bernstein after its discoverers. Given the amount of sunlight it reflects, astronomers speculate the object's diameter is somewhere in between 60 to 125 miles, 100 to 200 kilometers. That's an insanely big number. To compare, an asteroid that wiped dinosaurs out of existence is thought to have been just around 6 to 9 miles wide, 10 to 15 kilometers. But since Bernardinelli Bernstein is still so far away, it's not clear whether the calculations are close to real measurements. Another fascinating fact about this comet is that the last time it entered our solar system was 3 million years ago. That is about the same time a well-known human ancestor Lucy lived. Given such a long orbital period, it seems the comet should have come from a very distant place. And it happens there's just such a place believed to be home to trillions of comets. It's a place called the Oort Cloud, a spherically shaped region of space containing various remnants from the early ages of our solar system. The Oort Cloud is located far beyond the dwarf planet Pluto and might stretch to 100,000 Australian dollars from our star. So scientists think Bernardinelli Bernstein is the most remote comet we've successfully spotted on its way to us. Such an early discovery gives us plenty of time to study this comet and eventually explain its nature. So when will it get close to us? According to scientific estimates, the closest encounter with the Bernardinelli Bernstein comet will come in 2031. So far, astronomers claim the comet imposes no threat as it will fly by at a significant distance from us. The closest it will get is 11 astronomical units. That's about 10 times farther away from the Sun than the Earth. It won't even be visible in the sky with the naked eye. But since comet behavior is hardly predictable, we don't know what to expect. The asteroid, unlike Bernardinelli Bernstein, certain celestial objects will get much closer to us and a lot sooner. One of such space guests is a killer asteroid that will fly by within less than 7 cents. In just about a year, a binary asteroid named Didymos, accompanied by the smaller Didymoon, will make a near-Earth approach. The bigger asteroid is roughly 780 meters, roughly 2,500 feet, in diameter, while the smaller one is just about 160 meters, approximately 500 feet. However, that's more than enough to make a crater that is 6 miles wide and demolish entire cities. Even space rocks that are 500 feet, 150 meters, wide are capable of exploding with the energy equal to a nuclear bomb. A meteor, a tiny piece of an asteroid or a comet, that exploded over Chelyabinsk, Russia, created a massive shockwave. As a result, tons of buildings were damaged, and roughly 1,500 people were injured. And it was only about 65 feet wide, about 20 meters. But data concerning asteroid impacts has become even more disturbing. NASA has recently conducted an experiment that proved we wouldn't be able to do anything about an asteroid heading straight toward us, even if we had. A 6-month warning. The simulation of the hypothetical scenario involved an asteroid at a distance of 35 million miles, more than 56 million kilometers. Throughout each phase of the exercise that lasted a week, scientists received more and more data about the asteroid. They found out about the object's course, odds of it hitting our planet, and its size. But they couldn't come up with a working solution to deflect it. Turns out, We haven't yet invented a spacecraft that could eliminate such a threat within 6 months. In fact, such a mission would take us 5 to 10 years. In the simulation, the asteroid would have landed on Eastern Europe. In fact, the only way to escape the big rock was to evacuate the impact area, and that's not helping us too much. But as we know, some things that don't work out in theory can show good results in practice. So now NASA plans to smash a spacecraft about the size of a refrigerator into the smaller Didymoon asteroid that we mentioned earlier. The mission is called Double Asteroid Redirection Test, or DART. The idea is to take the half-ton spacecraft and crash it into Didymoon at around 4 miles per second, 6.6 kilometers per second. The launch will take place sometime between November 24, 2021, and February 15, 2022. However, the collision should happen between September and October 2022. This is going to be the very first test using the kinetic impactor technique to alter an asteroid trajectory and speed, and will be a kind of military training in terms of space. Now, Didymos doesn't threaten Earth yet, but NASA's database contains more than 2,000 potentially hazardous asteroids that can get as close to us as 0.05 astronomical units, around 7.5 million kilometers or 4.6 million miles. Asteroids and comets are often hard to detect, even with the most advanced technology, but at times, people equipped with homemade telescopes make huge discoveries. Just 2 years ago, an amateur astronomer named Gennady Borisov stumbled across a celestial object with a peculiar trajectory. Turns out, he found a comet and not an ordinary one either. It was later discovered by scientists that 2I Borisov is a rogue comet. This is because this type of a comet has no steady orbit, and will freely float through space until affected by another celestial object. As astronomers continued to study 21 Borisov, they used NASA's Hubble Space Telescope and Atacama Large Millimeter Array, ALMA, to figure out the comet's extraordinary composition. It had an abundance of carbon monoxide they didn't expect to see. And knowing about this high concentration of CO, scientists can make assumptions about its origin. So far, astronomers have come to the conclusion it should have been created in a place overflowing with CO ice. Such an abundance of CO ice is only present in space regions with a temperature below minus 420 degrees Fahrenheit, minus 250 degrees Celsius. There are 2 theories about how the comet formed. It could have been born around a red dwarf, a relatively small star with a low surface temperature. Otherwise, it could be a tiny fragment of a dwarf planet. This has become the first comet that entered our solar system from a place outside of our star's influence. But this is not the only thing that captured astronomers' attention. When approaching a star, a comet's particles start to melt and generate a fuzzy cloud around its nucleus. This cloud is called a coma. So what scientists noticed was a unique polarization in Borisov's dust grains. Now, polarization is the direction light waves ripple in space. The higher the polarization, the more focused the light is in a single direction. That's exactly what 21 Borisov's coma demonstrated. In the scientific community, this was a big deal. Similar to the way our skin reacts to direct sunlight, the more a comet interacts with a star, the bigger the impact on its materials. Eventually, the polarization of the comet's coma gets reduced. But what we see with Borisov's comet is quite the opposite. This can only mean one thing. It has rarely or never bathed in a star's light, radiation, or winds. So it is one of the most untouched and well-preserved comets we've ever detected. This leads us to the conclusion that the comet contains unaltered information about the materials that formed it in the first place, which could have happened some thousands, millions, or even billions of years ago. And since astronomers believe the birthplace of 21 Borisov partially resembles our solar system, the comet can reveal valuable information about another solar system much like ours. Borisov's comet already traveled past our sun in 2019. But this doesn't mean there are no other celestial objects only about to visit us. We can only hope our telescopes will look in the right direction and at the right time so that we can prepare ourselves once they show up. Outro, it seems no matter how fast we technologically evolve, this is not quite enough to ensure absolute safety and tranquility. Still, the most powerful resource we've got is our brains. So it's crucial that more and more people get involved in space science. To stay up to date about other amazing things happening in our universe, make sure to stay tuned here. Thanks for watching.